NEC Article 695.4 addresses the overcurrent protection requirements for fire pump motors. This section of the National Electrical Code is critical for ensuring the reliable operation of fire pumps, which are essential for fire suppression in buildings and other facilities. The primary requirement outlined in NEC Article 695.4 is that the overcurrent protection for fire pump motors must be capable of carrying the locked rotor current of the motor for a minimum of 10 seconds. Locked rotor current, also known as starting current, is the high current drawn by the motor when it is initially energized and before it reaches its normal operating speed. This current can be several times higher than the motor's full load current. The purpose of requiring the overcurrent protection to withstand the locked rotor current for at least 10 seconds is to prevent nuisance tripping during the motor's starting phase. Fire pump motors need to start reliably, and premature tripping of the overcurrent protection due to the high inrush current could prevent the pump from operating when it is needed most. The 10-second duration allows the motor to accelerate to its normal operating speed, during which time the current draw decreases significantly. This ensures that the overcurrent protection only activates in genuine overload or short circuit conditions, rather than during the normal starting transient. In practical applications, this requirement means that the circuit breakers or fuses used for overcurrent protection must be carefully selected and sized to accommodate the motor's locked rotor current. This is typically achieved by choosing overcurrent protection devices that have an adequate interrupting rating and can withstand the initial surge of current without tripping. To apply NEC Article 695.4 effectively, it's essential to understand how to determine the locked rotor current of the fire pump motor. The locked rotor current is usually specified in the motor's nameplate or in the manufacturer's data sheets. It is often expressed as a multiple of the motor's full load current. For example, the nameplate might indicate a locked rotor current that is 6 times the full load current. Once the locked rotor current is known, the overcurrent protection devices can be selected to meet the 10-second withstand requirement. This often involves using inverse time circuit breakers or fuses that have a time delay characteristic, allowing them to handle the high starting current without tripping immediately. In situations where a transfer switch is used to supply power to the fire pump motor from multiple sources, such as a utility power supply and an on-site generator, the overcurrent protection requirements apply to both power sources. This means that the circuit breakers or fuses on both sides of the transfer switch must be capable of carrying the motor's locked rotor current for at least 10 seconds. This ensures that the fire pump can start and operate reliably regardless of the power source being used. It is also important to consider the coordination of overcurrent protection devices in the fire pump circuit. Coordination involves selecting and setting the overcurrent protection devices so that the device closest to the fault will trip first, minimizing the extent of the outage and preventing unnecessary tripping of upstream devices. In the context of fire pump circuits, coordination is crucial for maintaining the reliability of the fire protection system. For example, the overcurrent protection device for the fire pump motor should be coordinated with the overcurrent protection devices for other essential loads in the building, such as emergency lighting and fire alarm systems. This helps to ensure that a fault in the fire pump circuit does not disrupt the power supply to these other critical systems. In addition to NEC Article 695.4a, there are other requirements in NEC Article 695 that relate to the overcurrent protection of fire pump motors. These include requirements for the location of overcurrent protection devices, the interrupting rating of the devices, and the coordination of the devices with other components in the fire pump circuit. It is important to consult the entire NEC Article 695 to ensure that the fire pump installation complies with all applicable requirements. Furthermore, it's worth noting that the specific requirements for fire pump installations may vary depending on the local codes and regulations in effect. In some jurisdictions, additional requirements may be imposed to enhance the reliability and safety of fire protection systems. Therefore, it's always advisable to consult with local electrical inspectors and fire protection authorities to ensure that the fire pump installation meets all applicable requirements. In summary, NEC Article 695.4 requires that the overcurrent protection for fire pump motors must be capable of carrying the locked rotor current of the motor for a minimum of 10 seconds. This requirement is intended to prevent nuisance tripping during the motor's starting phase and ensure that the fire pump can start and operate reliably when needed. Applying this requirement effectively involves understanding how to determine the locked rotor current of the motor, selecting appropriate overcurrent protection devices, and coordinating the devices with other components in the fire pump circuit. Compliance with NEC Article 695 and other applicable codes and regulations is essential for ensuring the safety and reliability of fire protection systems. The purpose of the 10-second requirement in NEC Article 695.4 is to allow the fire pump motor to start reliably without tripping the overcurrent protection. Fire pump motors draw very high currents, known as the locked rotor current, when they are initially energized. This current can be several times higher than the motor's normal operating current. If the overcurrent protection were to trip immediately upon sensing this high current, the fire pump would not be able to start, which could have serious consequences in a fire emergency. The 10-second duration provides a window of time for the motor to accelerate to its normal operating speed. As the motor speeds up, the current draw gradually decreases until it reaches the normal operating level. By allowing the overcurrent protection to withstand the locked rotor current for 10 seconds, the motor has sufficient time to reach its normal operating speed without tripping the protection. This ensures that the fire pump can start reliably and provide the necessary water flow for fire suppression. In practical terms, this means that the overcurrent protection devices used for fire pump motors must be specifically designed or selected to accommodate the high starting current. Ordinary circuit breakers or fuses may not be suitable because they may trip too quickly in response to the locked rotor current. Instead, inverse time circuit breakers or time delay fuses are often used. These devices have a characteristic that allows them to withstand high currents for a short period of time without tripping, but they will trip quickly if the current remains above a certain level for an extended period. The selection of overcurrent protection devices for fire pump motors should be based on the motor's nameplate data, including the full load current and the locked rotor current. The manufacturer's data sheets for the overcurrent protection devices should also be consulted to ensure that the devices have the appropriate time current characteristics for the application. In addition to the 10-second requirement, NEC Article 695 also includes other requirements related to the overcurrent protection of fire pump motors. These requirements cover topics such as the interrupting rating of the overcurrent protection devices, the location of the devices, and the coordination of the devices with other components in the fire pump system. It is important to comply with all of these requirements to ensure that the fire pump system is properly protected and will operate reliably in a fire emergency. The interpretation of NEC Article 695.4 is generally straightforward. The overcurrent protection for fire pump motors must be capable of carrying the locked rotor current of the motor for a minimum of 10 seconds. This means that the overcurrent protection devices must be able to withstand the high starting current without tripping during the motor's acceleration period. However, there can be some nuances in the interpretation of this requirement, particularly in situations where the fire pump motor is supplied from multiple power sources or where there are other components in the fire pump system that could affect the overcurrent protection. For example, if the fire pump motor is supplied from both a utility power source and an on-site generator, the overcurrent protection must be capable of carrying the locked rotor current from both sources. This may require the use of overcurrent protection devices with higher interrupting ratings or different time current characteristics. Similarly, if there are other components in the fire pump system, such as a transfer switch or an automatic starting controller, these components must be properly coordinated with the overcurrent protection to ensure that the system operates reliably. In some cases, it may be necessary to consult with a qualified electrical engineer or fire protection specialist to ensure that the overcurrent protection is properly designed and installed. The application of NEC Article 695.4 to a specific situation involves several steps. Firstly, the locked rotor current of the fire pump motor must be determined. This information is typically found in the motor's nameplate or in the manufacturer's data sheets. Secondly, the overcurrent protection devices must be selected based on the motor's locked rotor current and other factors such as the interrupting rating and time current characteristics. Thirdly, the overcurrent protection devices must be installed and configured in accordance with the NEC and other applicable codes and standards. Finally, the fire pump system must be tested to ensure that it operates properly and that the overcurrent protection is functioning as intended. In this specific situation described, the circuit breakers on both sides of the transfer switch serve as the overcurrent protection for the fire pump motor. These circuit breakers must be capable of carrying the motor's locked rotor current for at least 10 seconds without tripping. Since the circuit breakers are rated at 150 amps, they must be able to withstand the motor's locked rotor current without tripping. If the motor's locked rotor current exceeds 150 amps, the circuit breakers may need to be replaced with higher rated devices, or inverse time circuit breakers may need to be considered. It is also important to verify that the circuit breakers have an adequate interrupting rating to handle the available fault current at the location where they are installed. The interrupting rating is the maximum current that a circuit breaker can safely interrupt without being damaged. If the available fault current exceeds the circuit breaker's interrupting rating, the circuit breaker could fail to interrupt the fault, which could result in serious damage or injury. In conclusion, NEC Article 695.4 requires that the overcurrent protection for fire pump motors must be capable of carrying the locked rotor current of the motor for a minimum of 10 seconds. This requirement is intended to prevent nuisance tripping during the motor's starting phase and ensure that the fire pump can start and operate reliably when needed. Applying this requirement effectively involves understanding how to determine the locked rotor current of the motor, selecting appropriate overcurrent protection devices, and coordinating the devices with other components in the fire pump circuit. Compliance with NEC Article 695 and other applicable codes and regulations is essential for ensuring the safety and reliability of fire protection systems. Additionally, the indefinite period mentioned suggests that the overcurrent protection shouldn't trip at all during the starting phase, provided that there isn't an actual fault. The breakers must be sized appropriately to handle the inrush current without any possibility of tripping during normal operation. The 150 amp rating is a starting point, but the specific motor characteristics dictate the final requirement.